Isaac Newton, inventor of calculus, laws of gravitation, the milling on the side of coins, anti-counterfeiting, Isaac Newton. So why is there a death mask of Isaac Newton? Well, because he was a notable persona back then. And that was the kind of thing they did. They did that sort of thing. And secondly, I met the original of this, which looks like this, at the Royal Society last year. He's reminding me of someone. Is it Robin Williams? Does it look a little like Robin Williams? At any rate, I visited the Royal Society last year in London, and it was a transformative experience. Totally amazing, astounding. And when I was there, they brought out Isaac Newton's death mask. They have it there. They have the original. This is it. This is a crazy object. It's insane. And it's in an archival box. And it's in an archival box. I just keep wanting to puppet him. Which means it's in a cardboard box. And Brady Heron and I were laughing and saying, like, it should have it could use a better container. And so I made the offer to the Royal Society. I was like, I could build a container for Isaac Newton's death mask. I could build something that would hold it, perhaps in a more refined. Look, it's doing fine in a cardboard box. And I think we should talk about what I mean when I say archival. Wait, actually, let me get to the point of this video, which is already, you clicked on the title, you understand. I'm going to build a new container for Isaac Newton's death mask. I'm going to bring it to the Royal Society, and we will transfer Isaac Newton's death mask from its cardboard box into the box that I am making. Nothing could make me more excited. I am so freaking happy about this. This is like crazy great. So, I have some plans. I have not determined exactly what those plans precisely are at this second, but I'm going to mock it up in foam core right now. Yeah, I'm going to mock it up in foam core today. And then I'm going to build it out of some more solid materials. But let's talk for a second about archival things. Archival is a specific term of art in art and storage of antiquities that means no further damage will befall the thing within its storage. So archival storage is storage that's not adding any chemicals or exposure. Both are problems for antiquities. Exposure to ultraviolet light, exposure to temperature and humidity changes, exposure to touching and manipulating by people, and by chemicals. So in the olden days, they would build boxes out of wood and put their stuff in them. But wood is a natural material made of compounds of probably tens of thousands of different compounds that make up what wood eventually is. And some of those compounds deteriorate, they off-gas, they release some of their chemistry, and those gases can damage things. When you are at the art store and they said they sell you acid-free paper, well, what isn't acid-free paper? Newspaper is not acid-free paper. It's one of the reasons it turns yellow. Look, I might be wrong. It's been a long time since I looked that up, but I believe that's what the case is. So acid-free papers are papers that will not change over time. They will remain stable. And within art conservation, there are all sorts of different delineations of archival aspects. And look, people ask me all the time about whether or not I use 3D printing in my process. And part of it is, the answer is mostly no. Part of the reason for that is that the practice in here is meditative and healing for me of working with my hands. And so the getting there to the object by physically making it is what the endorphin release is based on. But the other reason is that most 3D printing processes are not super archival. Resin printers, certainly mostly not archival in my experience. I've had prints sit on the shelf that slowly deteriorate over time. They can also be more, they can be more vulnerable to ultraviolet light. My favorite 3D printing process is what this is made out of, which is sintered nylon, highly stable, I believe pretty archival. Nylon, more archival actually than Delrin, one of my favorite materials, Delrin. Let me grab a chunk here. Here we go. Delrin, whose chemical name is acetyl, I think Delrin's a brand name. Acetyl is a great plastic. It's a machining plastic. It's bearing plastic. It's one of the bread and butter materials in this shop. There is no Delrin up on the International Space Station. And the reason for that is Delrin off-gases. Delrin never stops releasing a little bit of, I don't know if it's deterioration that is off-gassing, but yeah, I'm not sure if it's officially deterioration from a chemistry standpoint, but it's always releasing some chemistry. And that chemistry can damage old things in spectacularly unknowable ways. And so the goal for me is to build a highly stable, completely inert box that releases no chemistry whatsoever to damage this priceless artifact. I might make two of these, one for myself and one for the Royal Society, because, well, I got to have one to house my Robin Williams. And the cardboard box that I first met Isaac Newton's face in is totally archival. It is acid-free cardstock, heavy paper with crimped metal corners. It's very durable, and museums the world over protect all of the most important things with effectively cardboard boxes. So there's nothing wrong with that per se. And I'm going to go overboard in the building of my box. And the reason is because I can. Look, museums have, I mean, the Royal Society, I don't know what their budget is, but like they have a lot to take care of that requires infrastructure, and that infrastructure has a cost, a direct cost. And so they go for the less expensive solutions. That doesn't mean they're any less durable. They're just less expensive. Hence why Newton is in a cardboard box. I don't want anyone to think that somehow the Royal Society is like asleep on the job and not storing their collection correctly. They are totally. But I am just one guy with my own shop, and I can afford to get some aluminum and make a ridiculously over-engineered box for Isaac Newton's death face. And give that to the Royal Society. And my hope is that the box itself will survive the collapse of that building if such a thing were to happen. Oh, right. So what you can see here is a sort of mix of organic forms and then these facets here, this arrangement of triangles, as it were, polyhedra. That is I'm going to cut this along the line of its transition so that I have an accurate, here's the death mask from the side. You'll see it's not in the most spectacular shape. It's plausible that that's what came out of the mold when they first did it. Yeah, how would they mold a dead guy's face? They would use a soft plaster to do the negative. And they would literally, just like the guy's dead, they'd go to the corner, they'd like slather some plaster on the dead guy's face. Then they pull that off once it sets, which is only a few minutes. It's an exothermic reaction. That's why plaster gets hot when it sets. They pull it off. Then they pour a stone plaster, something much harder, into the negative. And then they literally hammer off the soft plaster. I can't believe this works, but this is really how it's been done for millennia. Millennia? Okay, hundreds of years at least. So yeah, the first thing is for me to cut. And I have two prints of Isaac Newton's face, and I've already drawn the line here in Sharpie all the way around the perimeter, and I'm about to cut that. Then I will break out some foam core and some hot glue. I'm already heating up my hot glue gun. And I will mock up Isaac Newton's death mask archival storage box. This is great. I'm super psyched. What I've got here is a reciprocating saw, but that speed will just melt this nylon. So I want to put a regulator in line with the feed. Oh. Crazy. All right. Well, that will do. Let's open up a hole here. I think I'm just going to go around and do this and then sand it back. Here's the last one. Come on. There we go. Oh, look at that. .5 centimeters. That's how high that is. I printed these the wrong size. So, gonna print them again, and then we'll be back to this. I thought I should show you my hardware. So, in addition to 6061, I'm going to use these aluminum handles, one on either side, and I've got stainless 832 button heads there. For the hinges for this box, I have an old pair of Nagra hinges. These are aluminum, and I've got some stainless metric screws that fit those. For the closure, I've got these wonderful stainless, I've got these. They're stainless, they're lockable if one wanted to, unnecessary. However, it's possible. And I've got all the hardware I need for that. That is also going to be metric. We're gonna have a mix of metric and imperial fasteners. Not much to say. I've been mucking about, and I've got a box that I'm happy with. It fits all the hardware that I have. I like the handle there. I like the closing clasps. They're a little large, but I don't mind that. We can pull those into here. That's all the hardware. And then we've got here, this will open like this. And then the face will sit here. Look at that. Look at all that room around. Right. Signature. I'm currently toying around with the idea of etching Isaac Newton's signature into the top of this. That is an idea that I have. That is what it would look like. And then it would have the handles here. I mean, that's kind of great. I kind of like that. It opens like that. Pull out Newton. Amazing. Okay, I think this is enough to get started. Oh, right, so I think it would go like this. I would have .55. Are they consistent? All right, that's what we're gonna do. We're gonna do it that way. I like that size. I am going to cut this box, and then I'm gonna cut this box. This is stealthily tricky. I have a material here whose thickness varies here and there by a thou or two, but that can still throw you off. And I'm gonna have what'll end up being 32 tiny screws. 16 on either side and 16 top and bottom. 32 tiny 440 screws, stainless, these guys. And if I'm off by even a tiny amount, I could be screwing whole parts here. So I have to move methodically and carefully. I know that the two main defining pieces are the top and the bottom. Now let's put Newton's name there. So my two main pieces, top and bottom, they're going to be 12 by 7 and change. So I'm going to cut them about 1/8 of an inch over, and then I'm going to square them up on the mill. Is that really what I'm going to do? So the issue that I'm dealing with is that I've got these pieces of aluminum that are going to be this big, 7.5, give or take, and 12. And I want to maintain perfect squareness and parallelism among all these sides. And that's it's just a larger object for me, and I have to think through it. It's not necessarily super complicated. It's just, I want to make sure I get it right. This piece of aluminum is exactly 12 inches wide, and it's manufactured that way. It's actually extruded in this form factor. It's not made in a sheet. This is a extrusion edge. So I am going to yeah, that means I don't necessarily have to, I still need the angle plate over on the mill for drilling the edge holes. All right, so what I want to do is I want to cut 2 of these at 7.5. Yeah, that's it. All right, the fact is I'm being slightly lazy because I don't want to have to keep tramming in the vise, but I'm going to have to keep tramming in the vise. So I'm going to pull the vise and I'm going to pull the vise and clamp these directly to the table. Something I've always been able to do, but I've never done. Now, I'm going to clamp them all three together. Is that really the case? Yeah, I think that is exactly the case. Because I'm going to, yeah, okay. So, here we go. Let's pull those. Great. Oh, right, and this is 3/4. Yep. And okay. All right, what I'm doing now is I'm trimming all four sides to their exact full correct height. I'm gonna lift this and turn this whole thing over, and that should get me the parallelism I'm hoping for. That. Clean that out. Yep. Turn that over. I'm using the 1, 2, 3 blocks to spread a little more holding and clamping power up top. That is nice and tight. When I cut this, it should be totally parallel. I missed a mosquito. All right, so let's see here. All right. Nice, good, happy. I'm going to do this box the way I build all of my boxes, which is I'm going to build it monolithically and then I'm going to slice the lid out. I know it's aluminum, but I'm comfortable enough with the finish and operation I'm getting out of this big 3-flute high spiral cutting bit that I think that I can go and flatten both sides, and that means that the box joins itself. So, right, I think I can separate these out. I think yeah. So, oh. Lovely. Right. I've got to yes.
These are the same size.
I can still do that. Yeah, that's great. Like 375 inches from each end. So that means I do want a stop here that I can do for all 4 sets of these holes. Yes. Once I come up with the numbers, then I'm doing 4 and 4 and 4 and 4, and the numbers don't change. They just change direction, right? Yeah. And then these are, yeah, that can actually work in my favor. So I can do the stop here like this. Let's get a clamp. Right. I have 4 sets of holes, and so yeah, great. Yeah. Okay, so we're drilling 3 holes in either side of these, and just making sure yeah, it's the whole thing. So that's locked in, that's locked in. The diameter of my holes is going to be 1/8 of an inch. Jobber drills, here you come. 1/8 of an inch. That's it. And I think I can go with a 1/8. Yes, look at that. That's great. So here's what we're gonna do. And what we can do is we drill the 3 holes, and they are at, and let me make this mark, 7.034, 7.034. Yeah, I broke a tap. I said I couldn't afford to break a tap, but I broke one, and luckily I broke it in a way that is actually repairable and achievable, and I'm actually pulling it back out. And it was mostly because I was singing. I was like excited about the music. It reminded me of courting my wife. And there we go. One disaster mildly averted. Okay, so outside. Okay, outsides are all X's, 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 X's. Now, what I've got are these businesses. So if these, yeah. Now I've got the real task here. This is the tricky part. I've got to drill the tapped holes that allow these two holes to go into these guys. So, yeah, I'm gonna set that up. So play Wonderwall, a cover.
Here's Wonderwall,
the royalty-free version.
For every hole, there's three different sides. Look at my hands. For every hole I'm drilling, there's three different sizes. There's a through hole. That's 1/8 of an inch. There's a tap hole. That is a number 42 number drill. And I drilled the tap holes with through holes, which means that the 440 screws, I'll show you one. They go in these holes. How did I mess that up? Well, I wasn't going through my checklists, but I can fix that because what I can do is use helicoil and a little thread repair in there, and that's what I'm gonna do. We're gonna helicoil and fix these. Too scary. I'm gonna do it by hand. Okay, let's talk. The box is assembled. It's really darn close. It is hard, it is difficult to make a thing like this at this level of perfection. It is complex. And I've built it all monolithically, and so now I'm about to slice it, and I'm going to use a slitting saw. Yeah, I know. So, let's see. I was going to use the table saw, and then I remembered that I'm not stupid. It's not that it's no, that's a ridiculous thing to do. It really is. That would be, it's probably doable, but I'm not going to try it. I want to give a gentle bump to this. Wait, where is it? There it is. Oh, you broke, eh? I messed up. I didn't tighten this down. And the blade cracked. But because I didn't tie it down and the vibration was happening, it was climbing. The cut was climbing. So I mucked up a bunch of work I've already done. I'm letting it sink in. I can push this whole thing back to the next time I go to London. It doesn't have to be next month. I'm actually leaving for London in a week and a half. It doesn't have to be then. I can push it to the next time I go. Nobody's waiting on this. But here it is. It's 5:45, and I decided to take one last cut, and that's what happens. I can do a couple of things here. There's a couple of options open to me. I can... All right, this might not be such a total disaster. We will see. Ooh, I want to show this to you. Oh, what a horror show. Oh, yeah, love it. All right, let's turn this off. All right, I'm going to do a finished cut on this, and we'll see what we got. Success. Success-ish. I was able to... was going to pack out and go home, and then I realized I should show you where I got to. So my slitting saw did indeed climb, and it's the reason that the screws here are so close to the edge. I'm fine with that. Years from now, when you're visiting the Royal Society and they break this out and you see, and someone says, I wonder why they're so close. Tell them. I also have here my to-do list for tomorrow. I do have 2 more days to finish this if I need it. And I did clean up the inside edges. Look at that. Isn't that lovely? It is fascinatingly complex to make a big square thing. Little tiny differences really show and really feel. And I mean, right here, I'm within half a thou, and over here it's like a thou, and it's not cool, man. And I actually think it's quite adjustable. I think there's some movement I can do here, and you know, once I get this whole thing built, I'm going to take it all apart. I'm going to clean all the parts with chemicals and, you know, make them super, super clean. Then I'm going to put it back together, and I'm going to use Loctite in the, actually, I'm told, again, I'll have to look this up. I'm told that I might not need Loctite. Anyway, when you see me next, which is in just another shot or two, I will be proceeding with this to-do list. Hey, it's a new morning, and everything looks great. I'm really happy. You know what I love? I love this business. I love seeing the model. Oh, wait. Yeah, that is. I love seeing the model next to the thing as it's being built. This is one of my favorite tableaus. So I'm going to add 4 screws in the corner of this guy down here because, yeah, I wonder, actually, you know what? I could almost do it on the bottom. Yeah, I certainly could. I may do this in a kind of I need 4 more screws in here for the correct symmetries. And I'm considering a couple of methods of doing that. But it's going to be on the mill, so we're going to get started. I'm using the machine jack here to push this out. These original pieces of aluminum I was working with had a slight curve to them. They had a slight bow, and I positioned them each so I could take out that bow, give or take, and I feel like I succeeded. So here we go, last hole. Oh, I need new threads in you, I guess. Yeah, all right. That's not a problem. Okay, so that's that. Now it's time for the back, for the hinges. What put you on? Yeah. Hey. So, on the back, we have the hinges. Yep. And these, I think, are M3s. But we will learn soon enough. Dude. Yep. Very happy. That is really nice. So let's cross off some things here. We added 4 screws in the corners. We set up and drilled the hinge holes. We set up and drilled the handle holes. We have not drilled those. We have not done that. We have not done that. All right. That is one hell of a box. The hardware installation continues apace. I think, are these the same? They're not. They're totally not. Okay, so let us see how we're going to do this. I will center up on that guy. Yeah, come on. I almost got into real trouble there. The reason being is because these stainless clasps I have, these are boat hardware, and they're clearly kind of handmade. But the thing that I decided to check at the last second was, so I'd measured the distance across there, 675, and the height between these two, 575, but I did not confirm that both of these sets of holes were the same distance apart, and they were not. 675 here, 775 down here. Thank goodness I checked, because now all the holes line up, and I'm gonna get I'm gonna get that in there. Woo! Always check everything, says me to my own self. Okay. It's worth talking to you about helicoil. So what I've got here are some aluminum handles that I have put enough screws into and tested out that they're a little bit munged. And so what you do with a helicoil is it's basically this little spring whose cross section is exactly that of an 832 thread. And then you use this installation tool and you pop it in there. And you get it past the surface. Yeah, I'm going to go one notch past. And then what you end up with is a stainless thread that is sitting in there in the aluminum. It's a very, very positive grab. Now, at the bottom of the helicoil is this little arm, and that arm allows your installation tool to catch the arm and guide it in. And then once you've guided it in, past this point, past the surface. Wonderful. I will show you what we do next. So put the helicoil here on the installation tool. Now I can turn it. Now I feed it into the hole here. Doink, doink, doink. This is a absolute save your ass in a mission critical situation type of tool. Helicoil. They're also called thread repair. Oh, right. So that little arm thing, you get rid of that, and you get rid of it with a little knocker. Usually something like this. Sorry. Something like this. It's basically just like a little stick, and you do this and you hit it, and that little arm piece breaks off and comes out because the steel is hardened and super brittle, and that makes it ideal for snapping that little arm off, but because it's so hard, it is highly. So the demo I heard about these was that somebody stripped a hole in an aluminum block, installed a helicoil. There we go. And then stripped the head off the bolt once the helicoil was installed into the aluminum block, i.e. the helicoil put so much extra strength into the hole that the bolt's head came off before the thread stripped out of the aluminum. So yeah, I think that gets us where we want to go. Right, I want to file those down. And we are going to, right. Oh yeah, it's time. Okay, so that's the one. Excellent. Okay, so now I think we can put in the handles. And the handles are these guys. Here she is. Handles. Latches. Whole body is aluminum, as are the handles. All the hardware is real stainless. There it is. There's the case. Dude! Now I'm wishing I had made 2 of these because I don't want to make another. Because I wanted one for myself. I always want one of the things I make for myself. This is going to be hard to part with. I'm going to miss this. Okay, so wait, let's see where we are here. Set up and drill latches holes. Yep. Add 440 volts lid and corners. Yep. Make Teflon feet. Let's do that. Teflon, a marvelously inert substance, will make ideal feet for this. They will not scratch anything you put it on, and they don't off-gas. Delrin, of all things, off-gases. I know. So I'm just going to chuck this into the lathe and drill a through hole. I'll figure out what bolt I'm going to use to hold these on, and then I'm going to make 4 of them identically. So those are 3mm. Let's see here. Extra 440s. I may add some more. We're not positive. Actually, no. Optical punch coming back. I'm going to put these feet in using the drill press. I don't need to chuck this into an elaborate. Loading up the Teflon feet. Cleaned up a bit. It's nice to clean up between projects. Teflon feet and then the etching are the last thing before the final cleaning and spit and polish. Oh, right. And then I have to do the interior. That's a whole separate deal. So we're going to, yeah. So I've set a clean work surface. I'm laying my to be etched piece here. We're gonna get out some literal acid brushes. I'm gonna put on some gloves. Okay, here we go. I'm gonna pour a little bit of the ferric chloride into a cup and then pour it from there, rather than just dump it from the bottle. I'm not going to use a lot, probably less than that. Okay, here we go. Pouring in the etchant. Yeah, that should be enough. Oh, whoops. There we go. You can see it's already starting to bubble. Apparently you're supposed to move the bubbles away. So, washed, neutralized, and peeled. And there is Isaac Newton's signature. And it's a nice deep etch. It's dimensional. I think it's at least a couple thou deep. What is that? 0.05 of a millimeter? Anyway, yeah, 4th thou is 0.1 of a millimeter. Yeah, there we go. So I'm really happy. It's time to start doing some of the final fit and polish of this thing. And I'm gonna set up here. All right, I'm putting the finishing touches. This is the hard part of this project done, the actual archival case. Next, it's to get the foam and Tyvek and other parts that will seat Mr. Newton inside this box. But right now, I'm going to call it a day, a very good day. Yep, and get the hell out of Dodge. Here we go. Newton, look at his name. There it is. Don't wear it out. All right. See you in the morning. Next steps. I realized I've got to add a couple pieces of data to the outside of this. One, I forgot, I want to sign it, and I'm going to sign it here on the center of the bottom. Two, I want to make a little card holder for it. Something like, actually, sorry, I can't find it, but here's what it looks like. It looks like something like this with a window cut out here, and it would sit right here. So what you can see, yeah, that would look great right there. So this is me playing around and trying it for the first time using a chisel and a hammer. And so that's what I'm going to do. I'm going to make a little card holder. That's better than I thought I was going to get, to be fair. That's a nice little detail. How about that? Well, I'm pleased. That was my practice, and there is, with about an hour of work, my final. I didn't know I could do that. That's a nice looking part. That looks like a real thing. I'm very happy. Let's put it in. So we put one in. And then we put a second one in, and then we do the other two at once. This allows you room to fix your mistakes. Oh, it's finally here. It's finally here. We're almost done. Okay, so I have completed the physical form factor of the box. The hinges are lovely. The clasps are reliable. The opening is delightful. And this is a real suitable home for Sir Isaac Newton's face. It is time to line this and fill it with the foam for housing this guy. And in this, I'm going to follow some museum best practices, specifically in the choice of material and glue. So the material is some open cell polyethylene, which is a very inert substance. That means that over time, it does not change its chemical composition. It is not in a state of flux. It's not off-gassing. It's not releasing any volatile organic compounds or any others into the air. This is sort of like the bread and butter of museum storage. And still even, you don't let archival objects touch the foam, the ethylene foam. You actually use Tyvek, which is a non-woven, inert, Teflon-based fabric, I believe, Teflon. Anyway, my knowledge of its material composition notwithstanding, that is the general 1-2 punch of museum storage. Is you use the ethylene foam for the padding, and for any place in which the object is touching the foam, you line it in Tyvek. This is the same stuff they make the white painter suits out of, and specifically, you use this kind of low melt, hot melt glue. This is literally like the exact right stuff. It turns out that I already had it. That was awesome. So I'm going to be cutting some layers of this foam to fill this box, and then I'm going to be cutting them out to hold the face, and I'm going to also be making a part of the lid that also holds the face. Yeah. Let's get started. Oh, actually, first up is I need to cut all of this foam. Yeah, I need to cut this foam so it fits in here. So it fits in the box. So I'm just going to take these over to the table saw. Great. This is just what I wanted. So So let's see if this goes in here. Marvelous. The goal here will be that I'll do a little carve in here and make a patch of Tyvek so that if the head moves at all, it's just going to touch Tyvek, but it is going to be a this end up kind of thing, not really a carry it around like a suitcase sort of moment. And I'm also going to have to actually raise it up a little on the very bottom. So I almost want to, this is interesting. All right, I'm going to make some, I want that cut out of all three of these. And the question is, can I do that all at once? I think I can. That's pretty great. All right, I can use that to trace out the others. Awesome. That? Yes. Yes. Good. Now, it's incumbent on me to cut this out. Right. This. So that's where the real rubber meets the road, as it were. Yeah. Okay. So I want to cut that out of two of these. All right. I guess I could have cut this out in a slightly different order, but that's fine. Maybe. Let's see. I'm going to carve out something. It's got to be from here and there, where that's the low spot. And it comes back up to the high spot for that. Yep. Okay. And over here, there's another low spot, which is here. And that comes up to there and up to there. Okay, so I think I know what I need to do here. I think I want to come all the way around. I think I've gone to my classic too tight of a tolerance moment. Yes, that's where the cutouts are. I guess I just need one, and we'll lever it up and put it back down. It'll sit back in there like that, right? Yes, I think so. Time for some of the gluing. So this is low temperature melt. So I am going to, oh right, I do want to get rid of some of that. That's great. That is a great pickup. That's a great pickup point. Right, I've got time to get it into there. Okay, so there we go. We're gonna do, I'm gonna come in here. Yep, I'm gonna come in here. Yep, 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 okay. Yeah, we're doing it, we're happening. I got some glue in the corner there. Excellent. Okay, and we put this in, and we come down, and we go out to the edges. Out to all those edges. Yes. Yes, this is working. I'm gonna let that settle. Oh yeah, yep, gotta get in there, in there. Okay, this guy would sit there like that. Yep, see that? No pressure on it, nothing banging against him, nothing rubbing, not a tight fit, a regular fit. Okay, so now I wanna come down here on the sides. And so it's a kind of wanna, the nice thing about the low temperature, the low melt adhesive is that it does not melt the foam. It's not only archival, but it does not melt the foam. So if I put, oops, sorry. Put this guy in here. And if that lives there, it comes out like that. It's in there, it comes out like that. Right. And that means when his nose touches, I need to pull that out. So I want a patch here for his nose. And I'm going going to go with a slightly thinner piece of foam here. This, by the way, this entire case has been cleaned and scrubbed with acetone. So the case is clean. I'm very happy with the case. This comes in like this. This comes like this. Let's put this here. Right. And so I think what I want to do. Okay, it's kind of go to the right there. So the nose is here. Now, the weave. Yeah, definitely not touching. Okay, so what else do I need? I need okay. Very last step of this process is to make this. Is it to make that stand out? Yes, it is to make that stand out. I do want that to stand out. I'm going to use some acrylic, which when it dries is also inert, but it's also not that huge a deal because it's on the outside, not on the inside. Yeah. Okay. Well, I'm going to put it on here and then I'm going to peel it back off. That's how I do my stuff. Yeah, that's just slightly darker. I'm gonna get some Scotch right on there. Let's get a little more deep in there. Going with one more pass. Okay, great. Great. I'll just get rid of them. It's time for me to sign this. So I'm going to put this here, that there, right there in the middle, right? Yeah, right about there. And it is, yep, right by, let's see, it's on the bottom there. Here we go. This is me signing my work. Yep. Bingo! There it is. There, wait, here. There you go. And I'm just going to throw a little date down here. I know it's not the most beautiful signature, but it's on brand. May 2023. All right, let's get some paper towels, do some final cleaning here. Now he lives in there. That gets closed. We can peel all these guys up. There it is. There will be one final, I think, delivery of this in this video. Is that the next thing that's happening? Right, the delivery is the last part of this video. So now I'm going to pack this up in some craft paper and some padding and throw it in a pelican case so that we can take it to London and deliver to the Royal Society. But I am really pleased, and I like to imagine that if Isaac Newton was here, he would feel pretty comfortable about this as a resting place. Moment of truth. Hello, Keith.
Hi, Adam.
It's
good to see
good
you.
to see you.
And you have a box for me.
I have a box for you, and I really hope that it is the right size.
Cross everything.
Well, the scale pictures you took with measurements were fantastic. They actually included all the measurements that my brain wanted, and so we 3D printed one, and I have made it very close fitting, but it doesn't touch, right?
Yeah.
Like it's really holding it gently. So
I believe you got Newton's head in various sizes. Is
I
that
did.
right?
Yeah, well, the first one we printed up was a little too large, so I've got a 1 foot tall head.
Oh, that's a video. Newton's big head.
I will send that one to you.
Right,
You guys
great
can
stuff.
have that.
Great stuff.
And I've made this all out of inert archival materials. It's aluminum and stainless steel.
Brilliant.
And apparently the stainless steel screws that are holding it together will, over the next few years, have a reaction to the aluminum that will make them bond.
Right, okay.
And then all the materials inside are museum quality
Excellent.
PTFE and polyethylene.
Nice. Yeah.
Let's do it.
Okay, the great unwrapping.
I have also etched Newton's signature into
Brilliant,
the top.
that's lovely.
And I've included you a little
Oh yeah,
card
little
holder.
tag. We'll get the museum number in there.
There you go. I'm going to put that there. And I guess if you wanted to, you could lock it.
Yeah, yeah. And there he is.
There he is.
Wow.
In special effects shops around the world, because Robin Williams was in so many movies, there are masks, life masks of Robin Williams.
Yeah.
And Newton and Robin Williams are not too dissimilar.
They're not. There's kind of resemblance there. Yeah. It is a death mask. So
It is.
Newton would have been lying down and spreading out through
Gravity is
gravity.
having its effect, yes. And so, it only touches it around the edge here.
Okay.
This cutout for the nose doesn't touch this nose.
Right,
I
okay.
didn't want
So
any pressure on that.
we need to do that comparison between your mask and our mask.
Yes.
Here we go.
Oh my goodness.
Now this is quite a moment for me.
Is it?
Because back when I was a very young archivist, I made a temporary box for Newton's death mask.
You did?
I did in the 1980s. This is it. The temporary box became permanent when I left, and then returned to the Royal Society, and I was shocked to find it was still in there.
Amazing.
So, we're going to put this one to bed, or possibly in the Royal Society archives as a museum piece.
I love that
But
idea.
let's just take this out. Pop that on the floor, and here he is. Now yours looks smaller.
It does look
It looks a little smaller there.
It's hard to say.
Yeah.
So the way I
Let's
have
try
made
that.
it to go in is to beaver off the neck.
Mm-hmm.
Oh, it feels...
It's going to go. It's a fit, I think.
It's almost a fit. I'm not. All right, so it's not pressured against.
So we're
well,
slightly angled here.
I think it might.
Yeah.
Actually, I think it might not be the right size. Hold on.
Yeah.
Let's see what I wasn't seeing here.
I think the scale is just slightly out.
I think the scale is slightly out. I think that I might need to take the interior back.
Yeah. It's very close. I mean, it's millimeters.
Yeah, because the that. Yeah.
Yeah. Yeah.
There's one more pass.
Wow.
To make.
Yeah. Okay. So my box remains.
Your box remains the home. The box battle. I'm sweaty. Okay.
So 15 minutes probably took me to make this one. And how long did you say?
This was a 2 days.
Ah, right. Okay.
Two long days of machining.
I feel vindicated.
It actually turns out weirdly to be quite difficult to make a box where everything is really square and even and lines up.
Yeah.
Okay, so
let
me. I guess the one question I have, I just want to answer a question about the size.
Take that.
Maybe hold this to the back just
Yeah,
to
sure.
see.
Let's try that.
Wow, it is.
Sure, that is close.
It is so close, but there's some. Actually, the feature that's missing
Is the back.
this.
Yeah,
It's this
it's the back.
horn right here. And actually, there might be an ability, because height-wise,
Yeah, it looks pretty solid.
it does,
me.
but there's this.
It's just that
this
depth
little
and the packing
thing
out.
is not in my print.
Yeah, so you can see how this has been packed out with plaster at some time in its life. Probably, and you can see the rusty pins there, probably to display it in an upright position.
Right, of course.
So that's that little depth measurement that I think we've gotten a little wrong.
So I think that I actually, if you had a small blade, I might be able to clear away enough material because the Tyvek here is not glued on the side. I can peel it up, make a little space for it, and I might be able to accommodate that.
Okay, well we can try that. We can see if we can get a scalpel blade.
Let's give that
and
a shot.
just give it a whirl.
Yeah, it's just there. I just want to. I really am sweating. I had no idea that Keith built the original box. That's great. Oh my goodness, I need scalpels in my life. This is wonderful. All right, I think that is sufficient to see if we are in the ballpark. I've cut away a fair bit there and straight up so that accommodates that. So it should go back in here because it's a very slight pressure fit.
Take two. Here we go. Now then.
Okay.
No, that looks more upright.
That definitely looks more upright. I might not have cut down far enough.
Yeah.
But let's see how the... No, it's not down far.
Not quite there, but it's better.
It's way
definitely
better.
an improvement.
And it might be... I mean, I'm accommodating myself to the possibility I may need to take this home and make it just a tiny bit bigger. It is my one thing as an engineer is I tend to make things fit a little too close. And it limits my options later. Yeah, I guess if I have to take this home, then it's an adventure.
Yeah. Well, this is far more travel than Newton ever was in his lifetime.
Really? That makes sense. Okay.
Okay.
Oh, you know what?
It feels like it's not quite dropping.
Yeah,
it's
it
this,
feels
I think.
It's, there
kind of
too.
here.
You are right. It's right
Yeah.
there. I think we could do there too.
Yeah.
Okay. I think that might have been significant. Okay.
Here we go. He's feeling quite snug.
That seems pretty lovely.
Yeah. Oh, sir, you're a genius.
I am very relieved. There was no. It meets right
Yep,
up as
perfect,
it should.
perfect.
Incredible.
Yeah. Wow.
And I've also, I wanted to point out, I've included handles on both sides. So
Excellent. So it can be
transported
carried. Nice.
in a reasonable fashion as he's accommodated.
Indeed.
used to.
Yeah. Traveling in style. Very good.
Then I leave this box
That
with
is
you.
absolutely fantastic.
Thank
Adam,
you
thank
so
you
much,
very much.
Pete.
It's been
You
so
were-
much fun.
I have been so excited about this for months, and I really was fully prepared to take this home and
Yeah.
remake this or whatever I had to do. But
No, this is fine. And this, bin.
if you throw that out, I will take it. But I think you should put it in the archives.
and yes,
This
we
is a
need
bonus.
we need holes and some elastic. I think. Yeah.
You have made my season. Thank you.
You've made my day. This is fantastic. Yeah, and a signature. That's just such a nice touch.